So this is section 7.1, and we're talking about confidence intervals. And here's the idea. The idea is you want to be able to identify an interval, a lower bound and an upper bound, kind of like we did with standard deviations. And within that interval, you want to be able to say how confident you are that a certain value will lie within that interval. For example, let's say that we went out and we looked at a population. Okay, so let's say our population average, let's say we wanted to find or estimate the average height of every West Shore Community College student. So the entire population of West Shore student body, we want to find their average height. Well, it's not feasible to go out and actually measure every single student and find their height. And some students are probably still growing or maybe shrinking, their height's changing. And so what we would do instead is we would go out and we'd take a sample, okay? And we would calculate a sample mean, a sample average. So maybe we go out and we sample the students in the statistics class. So I say, okay, everybody report what your height is, and everyone reports their height, and I average it, and I get a sample mean, okay? From that sample mean, I can calculate something called a margin of error. So I can calculate a margin of error. And so I can take the mean from my sample and then add and subtract the margin of error to get an interval. For example, let's say you guys all report your heights. So you send your heights, I average them. And it turns out that the average height for people in the stats class, which is a sample of the West Shore student body, the average height happens to be 5'6", okay? And then I calculate, and this is what we're going to show you how to do. I calculate a margin of error. So let's say that my margin of error, we're going to call that E, is 3 inches. And this margin of error is dependent on how confident I want to be. So if I want to be, let's say, 95% confident, then my margin of error shakes out to be about 3 inches. So that means my lower boundary is going to be 5'3", and my upper boundary is going to be 5'9". And I could say with 95% confidence that the entire population average height is in that interval. Somewhere between 5'3" and 5'9" is the actual population average height. Okay, which I'll never be able to measure, right? Like I'll never be able to, but at least I can say with a 95% confidence. If I wanted to crank up the confidence as my confidence goes up, so let's say I wanted a 99% confidence interval, okay? As my confidence goes up, my margin of error actually goes up. So maybe this goes to 4 inches. And now it goes from 5'2" to 5'10". I get a wider interval. The more confident I am, the wider the interval has to become, okay? And so, and if my confidence goes down, the interval gets smaller, and we'll talk about that. But this is basically the idea of what we want to do. We want to say, I need to find a characteristic of the population, the mean of a population, the average of a population. But I can't go out and sample everyone. So instead, what I'm going to do is I'm going to collect a point estimator, which is the same measurement, but from a sample, okay, from a sample. And then from that point estimator, I'm going to develop a margin of error. And then I'm going to use that margin of error to add and subtract from the point estimator to get an interval, a confidence interval. And that's basically what all this says. So for example, this is a graph of a 95% confidence interval distribution, 95% confidence. So there's a couple key characteristics here. First of all, we'll start with the most common one, the confidence level, C, the confidence level. And I'm going to use a different color for this. I'm going to use red. So the confidence level, this guy right here, that is the area between the two boundaries, between the upper boundary and the lower boundary. So again, the confidence level. So as my confidence level goes up, right, as my confidence goes from 90% to 95% to 99%, the area gets larger, right? The area gets larger, which means my interval gets wider. My confidence interval gets wider, okay? So that's the confidence level. If I have a confidence level of 95%, then I also have what's called a significance level. And these two things are complements. So if my confidence level is 95%, my significance level is 5%. And that 5% is divvied up between the two tails. So 2.5% on the tail on the right and 2.5% on the tail on the left. Okay. And the same thing would be true if we changed the confidence level. So if I had a 90% confidence level, then my significance level would be 10%, split into 5% on the left and 5% on the right. Okay, get it? So we're looking at normal distributions, and we have these two levels. We have a confidence level, which is the area in the middle, and then we have something called a significance level, which is the area off the tails, one to the left and one to the right, and it's evenly distributed. And these two ideas are complements. They both add up to 100%, right? Or 1.0. The interesting thing is that the boundaries for these levels, so the boundary for the confidence level of 95% has a specific z-score. And remember what the z-score was. It was the number of standard deviations away from the mean. So the z-score for a 95% confidence level is 0.196, almost two standard deviations away is where you can be 95% confident, okay? And so if we scroll down a little bit, we can show you some other examples. So here's a 90% confidence level. So again, if your confidence level is 90%, that's this area. That means that your significance level is 10%, which is 5% on one tail and 5% on the other. And the z-score boundary, the z-score where this occurs, the boundary is negative 1.645 standard deviations below and negative 1.645 standard deviations above. Okay, so we're tying in previous information, this idea of a z-score. Okay. Then we can change this. So 95% confidence, that's the one we just looked at. And here's the z-score for that. And then 99% confidence. And you can see with 99% confidence, your area increases, right? You now have 99% of the area, which means you have 0.5% on this tail and 0.5% on this tail. And look what happens to your z-score. As your confidence goes up, your z-score goes up. The interval gets wider, okay? All right. So here are some more confidence levels and z-scores, just a table of common ones that might be used. If you want to find a complete table, you can click on this link and it'll take you to the Z table that'll show you all kinds of confidence levels, significance levels, and the z-score boundaries. And then this stuff I'll let you read on your own. This is about why we say things the way we do and some examples of confidence levels. But this is something that I wanted to show you. I want to show you these this last graph and the comic from Garfield. And this explains sort of what we're talking about. Once again, there is a direct relationship between the confidence level and the confidence interval. Okay, confidence level and confidence interval. As my confidence level increases, as I go from 90% confidence to 95% confidence to 99% confidence, as I get more confident, as the area gets larger, the interval also gets larger. There's a direct relationship between this, okay? And this is in the comic, the Garfield's watching the weather, and the weatherman says, taking a look at the tomorrow's weather, the high temperature will be between 40 degrees below zero and 200 degrees above zero. Okay. And Garfield says, this guy's never wrong. Well, of course he's never wrong, because his interval is so wide, he's guaranteed to predict the correct temperature for tomorrow, right? You're talking about a range of negative 40 degrees to 200 degrees, right? So he could probably be very, very confident that that the weather for tomorrow is going to fall in that interval, okay? However, if he made the interval smaller, right, he's decreasing his confidence area. So if he made this maybe 0 to 100 degrees, his confidence would go down. And if he made it even smaller, 40 to 60 degrees, his confidence might go down even more. So as your confidence level goes down, that area of the curve, this area right here, that's what you're changing. Okay. And we're going to get into a tech tool in Desmos where you can actually dynamically change this and see it happening. It's kind of cool. And so again, your confidence level is that area in the middle. So as that area gets larger, the interval gets larger. And as the area gets smaller, the interval gets smaller. And that's what's represented down here. And that's also sort of summarized by the cartoon of Garfield, because yeah, the guy's never wrong, because he's probably at 100% confidence because the interval is so wide.